handwriting recognition, playing a couple games. You've probably seen the same kind of games. I go way back. I really used to love the old Palm Pilots and the gesture recognition that they had there, and the graffiti handwriting recognition that they used. And really surprised that I haven't seen that used much at all. And so I thought I'd give it a try after playing a few games and that sort of thing. Kind of reminded me of graffiti, and so I thought I'd give a try trying to figure out how to do handwriting recognition and gesture recognition. I put out in the forums a link to the what I'm going to show you, so you might want to go out there and download the file that I put out there. It's in the meetup thread, so you might want to go ahead and grab a copy of that, and then you can kind of play along as we go. Okay, so I'm just going to open. Oh, I should open it up and play it. That's what we should do here. So I'll just go ahead and play it and kind of show what it does for a second. I need some feedback. Can you all see the screen? Is it showing up okay?
We see it fine here in Austin.
Okay, so it's showing up. Okay. Well, okay. So I just put together a little generic thing to kind of show how to do the basics of it. So you might notice here from the old Palm Pilot days, the graffiti handwriting. This is what graffiti looked like. And I used to practice that, and I could write in graffiti something quick. So I kind of missed it a little bit. So this is basically the idea. I'm going to use these letters. It's kind of been trained to do these letters here. And so I guess I'll just spell GameSalad as best I can here. I'm using a mouse. Let's see what we can do here. Mess that one up. Game. It's hard to do with a mouse. Writing is hard with a mouse. Is that showing up okay? Can you see the little dots on?
Yeah, we can see here in Austin. I haven't seen anything from everybody else, but I think you're okay.
Okay, so just the little outline of the dots there that kind of outline the words. That kind of shows up a little bit. Okay, so that's basically the idea, is using graffiti handwriting to or any other gestures you want as well to input into GameSalad so you can do things like that. And so if you go out to and download a copy of this out of the meetup thread, you can kind of follow along, and we'll just do that. Let's open it up, and so I guess I should say that this is the detector. The little spot that was doing the dots, that's all that is. This is a little graphic of the graffiti handwriting, and then down below is I should mention too that this graffiti, this image here, actually comes from Wikipedia. I just grabbed it off of Wikipedia as an image on graffiti and stuff like that. So please don't use this or anything like that. In fact, there's some lawsuits that are going on, or at least in the past there's been some lawsuits. People tried to use graffiti, and the folks who actually own the copyright to it sued and won successfully. So be very careful about using it. You can make up your own handwriting and that sort of thing. Well, okay, I'm just going to go into the gesture detector actor here. It's basically just one big actor that's on the screen. Open that up. So really all we're going to do is we're going to look at how to detect when the mouse is down when it's touched, and then how to record some stuff, and then some display. So we'll just go from there. I'll open up the first rule, gesture detection. And let me see, open up the group. So basically, all that's really going on here is that when that actor is touched, when it's pressed, we start to do some things here. We got some attributes to kind of to fill out first, just to kind of start things off. So these are really just initializing these attributes. We have an old X and an old Y. Basically, we're recording the previous X and Y location so that we can then see how far along the mouse has gotten from the old X and Y location of the touch, and determine how far the distance and stuff like that. We've got old direction. Now, direction will be the basically the direction that the cursor is moving in, since that's what we're trying to do, is detect those kind of angles and stuff like that. Letter guess is obviously the letter that we're trying to guess. See which letter it's trying to guess at. Let's see here. Oops. Letter guess. Oh, and then the current gesture number. I'll get to that in a little bit, but basically we're going to take and get all the angles and come up with a number, and from that number, then we're going to try and figure out what the letter is, from basically a compilation of all the different angles that it's as you draw. Okay, so that's kind of just setting up, initializing some attributes. Okay, and then the next part then would be to we'll actually start going through some of this then. First thing we do then is we want to see how far along the distance is the mouse has traveled since we recorded the old X and the old Y. And so we're just using the magnitude here, and we're looking at how far along it's gotten, the X and Y, the old X and Y versus the touches and the current touch. And just calculating that as the distance. When it's greater than 10, meaning when it's gone 10 pixels further than the last time it's checked, it's time to check some things again. So if you notice when we play this, about 10 pixels in, it starts laying down dots every 10 pixels, and that's basically what's going on there. Okay? So it's just detecting how far along those have gotten. So every dot there is basically about 10 pixels of the distance or so. Okay. Okay, so when it's reached about 10 pixels, then the first thing we're going to do is try and get the current angle that things are at. And so we use the attribute, and basically we're just looking at the current angle attribute. We're inputting this vector to angle. We're getting the old X and its current X, and old Y and current Y, and that'll give us the angle that things are going. So this is kind of what it looks like. What we're trying to do is detect all sorts of different angles, like all sorts of different directions. So that's an angle, that's an angle, different things like that. And then according to the direction it's going and the angle it's in, we start to build up an idea about what letter it is and that sort of thing. So those basically are the kind of angles. Now, I'll show this a little further as we get into it in a minute here. But basically, the direction looks like this. I'm just going to make a. This is really hard to do, I guess, with a mouse. So basically, all I'm really looking at are these directions like this. So going out this way is a direction. Just kind of heading due east. That's heading due east. That's heading due east. This would be north. That would be north as well. All of that would be north. Anything that's going in that direction, this would be west, like that. All of those are west, as long as they're kind of in that quadrant there. So those are basically the directions and the angles we're looking at, right? Kind of east, north, west, and south, and that's all we really had to detect. So that's kind of what's going on then when we're looking at this current angle here. We're just seeing how far along it's gotten. Okay. Just as soon as we've figured out what the angle is, then we just lay down a dot. That's that black dot that was showing up. Then we update the X and Y, the old X and Y location. So we're now basically getting the X and Y of where the dot was. and using that for the next iteration. So basically just trying to lay down a dot, then do another 10 pixels, and lay down a dot, do another 10 pixels. And every time we do lay down another dot, we check for the angle. Okay, and then once we get the angle from the previous dot to where the mouse is after 10 pixels or so, then we want to try and figure out what direction that is. So we've got just a basic angle, but angle was too fine of a detail. That's 360 degrees, and all I needed was basically 4 different cardinal directions. And from that, then you could kind of build up an understanding of what the what the letter is, if you get enough information from that. So basically, we're converting the angle to a direction, one of those 4 cardinal directions. And this is the expression that I came up to do that. So it's just grabbing the angle. It's adding basically 45 degrees to it, kind of putting it up on its side a little bit. Instead of a cross, it's making an X, and that's basically all it's doing. It's angling from basically going from something like this as the cardinal directions, right? Instead of that, it's going across this way instead. And that way it's easier, because if you have things up and down and left and right, too many of our letters are in that up and down, left and right kind of thing, and it's really hard. You might start on this side and jag over here and jag over there, and those look like separate angles and stuff like that. So it's easier if this is all one big area that it's kind of going. So we lay down a dot. So we get the old X and old Y. And then we get the direction. Basically, it's 1, 2, 3, or 4. That's really all it is. And then we figure out if the direction has changed. So, for example, let me see if I can do this here. So for example, this is all still going in the same direction, even though all those dots are being laid down. That's still the same direction, and there might be some slight variations in the angle, but the general direction is the same. And that's why I had that kind of X, that sort of thing. Okay, this is a general direction here, and so I don't want to record every time it's going in this direction. I just want to record when there's a change in directions. So in other words, this is all one direction, and it's just putting a 2 in there. You can see that right there, and it's just going to continue to put a 2 there until I actually change directions. Okay, so hopefully that explained that. So okay, so we get the direction. Now, if the direction changes at all, if the direction is different than what we've laid down, so we get the current direction, and if it's different than the old direction, then it's time to do a little bit of recording. So basically, then we record what's in the gesture number, and the gesture number is basically a multiple of some prime numbers. I think it was Tation was saying a few months ago, if you multiply some prime numbers together, the product of those prime numbers are always unique. And that kind of gave me the hint for doing this. If you multiply prime numbers by themselves, you come up with a unique prime number. And so over and over again, we're just multiplying whatever the gesture number is by a table cell value that's based upon the current direction. And I'll show that in a minute. And from that, then, it gives you a unique prime number that starts to build up and tell you what the actual letter is. Let's go look at those prime numbers. They're in a table. We'll go to the table prime numbers, and this is all they are. I just went out and grabbed the first 12 prime numbers, and in reality, all I really need are the first 4. Originally, I had this sliced quite a bit, had more angles and directions and that sort of thing, but really didn't need them. Didn't need much of them. So basically, I'm just using 2, 3, 5, and 7. And every angle then, every direction, 2, 3, 5, and 7, multiplied by the different direction it's going, gives you that unique prime number that starts to build up the actual letter. I guess the actual letter value. So those are just prime numbers. And so then all this was doing then was looking at that prime number. So was basically looking at that table and grabbing the prime number, and then from that multiplying it back to the gesture number, and that builds up the prime numbers. Okay, and then basically just recording the old direction so that we could start over again after that. So all of that was, as you can see it kind of happening here, was so that as you change directions and that sort of thing, you see that it starts adding up or multiplying those prime numbers. Right? I do a B. Starts looking like an I, and that's 7. And then you go around, and it starts multiplying those together. Pretty soon, it comes up with all those prime numbers multiplied together, gives you this unique number that designates that that's a B. Difference between a C and a G, right? Just kind of goes around and hits that tail there. Keeps multiplying those as that last angle there as well, or direction there as well, and that gives you a G rather than a C. So it's just, that's basically just kind of what it's doing. Okay. So getting the gesture number and then recording the old direction. After that, it's time to look it up. So we actually look up the letter. We're in the attribute letter guess. We're just basically then looking up the table that in a table those prime numbers and seeing which prime number, which number is associated with which letter. So it's a long little bit of a formula here, but basically it's looking in a search table to figure out which prime number goes with which letter, and then returns that letter. So we'll look at the prime number. There's the search table. So these are basically the prime numbers, and all I did was make those letters, gestures with the graffiti, handwriting, and then looked for the numbers that showed up. So A can be a 21 or a 42, depends on how your angles are, how light you make your angles and that sort of thing. B is that huge number, C is that, and so it's basically just looking up in this column to see what those prime numbers are, to see what those multiplied prime numbers are, and then whatever the number is, then it just goes out and grabs the letter. So you can see here some letters have different numbers as you kind of form the letter slightly differently every time. And so you can train it. You can build up all sorts of different letters and numbers and that sort of thing. They don't have to be these at all. Here's W. It's got 3 different ways you can make a W. So that's kind of the idea there. Looks up in this side the numbers, and then on this side gives you what letter is associated with that. And that's basically what this this search here is. The cell value. So that's basically all it's doing there. It's looking at it. Once it gets the number, then it once it gets the number and then gets the letter, then it's just time to record it on the scene. And so basically, I just did a little rule that says if you record a letter, anytime you hit the space bar, you're going to stick whatever is in the current letter guess, concatenate it to the phrase, to a phrase attribute, text attribute, and then have that show up. So that's where that was saying GameSalad across the bottom. And then also a rule that says if you hit the return key, then it just resets the scene. So you kind of erase the white part. So from that, then you can get all sorts of letters, right? Spacebar. Something like that. C. And if you hit enter, it just erases it all and resets the scene. So that's basically it. A real quick and relatively easy way to do letter recognition and gesture recognition. and can be really quite useful, especially when if you start wanting to make some games and do your own gestures. So I guess that's it, kind of in a nutshell. Questions or anything like that?
Yeah. How do you handle X when you pick up your hand?
Oh yeah. So let me go back and show what it looks like. Um, I've trained it to kind of use this graffiti handwriting system here. And in graffiti, in the good old days, Palm Pilots and that sort of thing, an X was just a diagonal like that, and that indicated it. The problem is that it's really difficult if you if you actually raise a stylus. The way I've got it set up, then it thinks it'll be a separate letter. So you notice that the A doesn't have a cross in it, a cross member in it, or anything like that. What you're looking for is to make letters that are just kind of one fluid movement, um, and not lift the. It's not like lifting the pencil or anything like that. But you can make your own gestures. I suppose you could come up with something that looked like that, if that kind of looks like an X to you or something like that. But yeah, you can't actually lift up and go like that. It'll give you something weird.
I just saw you said there about one fluid movement. Is there a way of combining two movements to come out with one letter?
Well, I bet you there is, but I'm kind of lazy and I didn't do that. So you would have to probably, like if you made an X, with one movement like that, and then maybe you'd hit the space bar, or maybe something over here that says continue the movement and then draw another one or something like that. So you can do that, but it would be an extra bit of work to do. Frankly, it's just easier to, in terms of writing and stuff like that, to actually just make it one movement.
Any other questions? Going once, going twice. All right. So I want to thank Richard for his time presenting this. It was great. Thank you so much for taking the time out to present for us, Richard. It was a great talk.
You're welcome.
Like I said, anybody's welcome to present. We have plenty of slots open for the rest of the year, so send me a message.
Next month, we're going to be talking about GameSalad graphics optimizations, and one of our senior engineers, Brian Hapgood, will be giving that presentation. Look forward to seeing you guys then.